There is a single number, and almost no one has ever heard of it, and it quietly decides how the entire universe ends. Physicists write it as one small letter, and everything hangs on whether it sits just above or just below the value -1. Sit above it, and the cosmos dies slowly, cooling into darkness over spans of time we can barely name. Slip below it, and something else happens entirely. The expansion of space runs away with itself, faster and faster, until it reaches down through every scale of the universe and tears it apart. Galaxy clusters first, then galaxies, then solar systems, then planets, and in the final fraction of a second, the atoms in your own body pulled apart by the growing of the empty space they are made of. We have measured this number to within a few percent. We have not measured it well enough to know which side of that edge we are on. So the honest truth is that the fate of everything currently rests on the sign of one number we cannot yet read. Get comfortable and settle in. Hit subscribe if you're new here. Because by the end of this, the empty space in the room around you will never feel quite so empty again. Now, let's slowly ease into this. Part 1. The number that decides everything. There is a single number, and almost no one has ever heard of it, and it quietly decides the fate of everything that exists. You will not find it printed on the front of any newspaper. It does not have a famous name like the speed of light, or the number pi. Physicists write it as a lowercase letter, the letter W, and it describes the behavior of the most abundant ingredient in the universe. And depending on whether that number sits just above, exactly on, or just below the value -1, the universe you are lying in tonight will end in one of three completely different ways. One of those endings is a slow cooling into darkness. One of them is a collapse, a reversal, everything falling back together. And one of them is a tearing, a moment when space itself pulls every atom in the cosmos apart, including the atoms in your own body. Tonight, we are going to sit with that third possibility, the tearing, the one physicists gave the almost unscientific name, the Big Rip. And the strange thing, the thing that makes this more than a story, is that we genuinely do not know whether it is coming. Not because someone is hiding the answer from us, but because the answer is written in a number we have only barely learned to measure. We have pinned that number down to within a few percent. We have not pinned it down well enough to know which side of -1 it truly lives on. And so the honest position of modern physics is not that the universe ends this way or that way. The honest position is that the fate of all structure, everywhere, forever, currently hangs on the sign of a single number we cannot yet read with certainty. Let me tell you why that number matters so much. Because at first, it sounds absurd that so much could ride on something so small. The universe, as far as we can measure it, is made mostly of something we cannot see and do not understand. Roughly 69% of everything is what we call dark energy. It is not dark matter, which is a separate mystery. Dark energy is stranger. It is not clumped into galaxies or wrapped around stars. It appears to be a property of space itself, a faint pressure built into empty volume, a pressure that does not pull things together the way gravity does, but pushes them apart. And the more space there is, the more of this pushing there seems to be. That is the ingredient that governs the long-term future. Ordinary matter and dark matter decide how galaxies form. Dark energy decides how the whole thing ends. And the number W is simply the way physicists summarize how dark energy behaves. It compares the pressure of dark energy to its density. You do not need the equation to feel the meaning. If that number is exactly -1, dark energy is perfectly steady, a fixed feature of empty space that never grows and never fades. And the universe expands forever, cooling toward a quiet end. If the number is a little greater than -1, dark energy is gentle, slowly thinning out over cosmic time, and the ending is softer still. But if the number is even slightly less than -1, if it is -1.01 or -1.5, then something happens that breaks every intuition you have about how the world works. The dark energy does not stay steady. It does not fade. It grows. It gets stronger as the universe expands. And a universe filled with a force that strengthens the more room it is given is a universe racing toward its own destruction. Notice what has happened here. We have taken the largest question a person can ask: how does everything end? And we have found that its entire answer is compressed into the position of one number relative to one value. Above -1, a slow death. Below -1, a violent one. On the line exactly, a third fate in between. The whole future of the cosmos balanced on a knife edge, and the blade of that knife is the value -1. This is the thread we are going to follow tonight, and I want you to hold on to it, because we will return to it again and again as the universe comes apart in front of us. Everything you are about to hear, the emptying sky, the loosening of the sun, the last 30 minutes of the earth, the final instant when atoms themselves let go, all of it depends on the sign of a single number, not on distant gods or cosmic accidents, on whether one measurable property of the empty space in this very room is a hair above -1 or a hair below it. For most of the history of science, we did not even know this ingredient existed. The idea that empty space could carry its own energy and push the universe outward was, for decades, considered an embarrassment, a mistake, a fudge factor that the greatest physicist of the 20th century supposedly called his biggest blunder. And then, at the very end of the 1990s, the sky forced the idea back into existence, because astronomers looked out at exploding stars in distant galaxies and found that the universe was not slowing down, as everyone expected. It was speeding up. Something was pushing. Something was winning against all the gravity of all the matter in existence. That something is what we now call dark energy, and understanding it is the whole game. So before we can watch the universe tear itself apart, we have to understand what dark energy actually is. This invisible majority of reality, this pressure hiding in the emptiness, this thing whose defining number will decide whether the stars go out gently or whether the cosmos is ripped to nothing while it is still full of light. And the first thing you should know about it is the thing that unsettles physicists the most. We can measure what it does with extraordinary precision, and we still have almost no idea what it is. You might wonder how a single letter came to hold this much power, and the answer is that physicists needed a compact way to describe the personality of any form of energy in the universe. Every ingredient of the cosmos, matter, radiation, dark energy, can be summarized by how its pressure relates to its density, and that ratio is what the letter W captures. For ordinary matter, the value is essentially 0, because a cloud of dust has almost no pressure. For radiation, it is 1/3. For dark energy, it is close to -1, which is what makes dark energy so unlike anything else. It has a large negative pressure, a pulling tension, rather than a pushing crowd. So when we say the fate of the universe rests on whether W is above or below -1, we are really saying it rests on the exact personality of the strangest ingredient there is, on whether its tension holds steady, relaxes, or tightens. One letter, standing in for the character of the emptiness, and through it, for the character of the end. Part 2. What dark energy actually is. Empty space is not empty, and it is not passive. That single sentence is one of the hardest things in all of physics to truly accept, because everything in your daily life teaches you the opposite. You think of empty space as nothing, the absence of stuff, a stage on which stars and planets act out their motions, a container with no properties of its own. Remove the air, remove the light, remove every particle, and what is left should be pure nothing, inert and featureless. But that is not what the universe reports back to us. When physicists take the emptiest volume they can imagine and ask what energy it contains, the answer is not zero. Space itself appears to carry energy, everywhere, at all times, and that energy pushes. Let me try to make this less abstract, because it matters for everything that follows. Imagine you could take a perfectly sealed box and remove everything from it. Every atom of gas, every particle of dust, every photon of light. You would have what anyone would call a vacuum. Now here is the strange part. According to our best physics, that vacuum still has an energy associated with it, a kind of baseline hum built into the fabric of space. And unlike the energy of matter, which pulls inward through gravity, the energy of the vacuum pushes outward. It has what physicists call negative pressure, a tension, a stretching quality, as if space were faintly trying to inflate itself. On the scale of a box, you would never notice it. On the scale of the entire universe, where there is far more empty space than there is matter, it becomes the dominant force in existence. This is dark energy. It is not a substance floating in space. It is, as best we can tell, a property of space. Wherever there is volume, there is this faint outward push. And because the universe is overwhelmingly made of empty volume, the space between galaxies dwarfs the galaxies themselves by an almost unimaginable margin. This gentle push, summed across all that emptiness, becomes the thing that steers the future of everything. The simplest version of this idea is called the cosmological constant. In this picture, the energy of empty space is a fixed number, a constant, unchanging property of the vacuum. Double the amount of space, and you double the total dark energy, because each new patch of vacuum carries the same energy as the last. But crucially, the density stays the same. Every cubic meter of empty space carries the same tiny amount of this pushing energy as every other cubic meter, and that never changes no matter how much the universe expands. In this version, the number W is exactly -1. This is the tame case, the well-behaved case, and it leads to a universe that expands forever, faster and faster, coasting into a cold and quiet future. Most physicists, if you force them to bet today, would bet on something close to this. But, and here is where the thread from the first part returns, the cosmological constant is only one possibility, the one that sits exactly on the knife edge at -1. Dark energy does not have to be a fixed constant. It could be something more dynamic, a field that fills space and changes slowly over cosmic time. Physicists have a name for that gentler version. They call it quintessence, after the old idea of a fifth element beyond earth, water, air, and fire. In the quintessence picture, dark energy slowly thins out as the universe expands, its number W sitting a little above -1, and the ending it produces is softer than the constant case. And then there is the other direction, the direction almost no one wants to be true, where the number slips below -1 and dark energy does the one thing nothing else in the universe does. You can already feel why that number is everything. It is not measuring some far-off object. It is measuring the character of the emptiness itself, whether the vacuum is steady, fading, or growing. And we cannot see dark energy directly. We have never held it, never trapped it, never watched a single particle of it. Everything we know about it, we know indirectly, by watching what it does to the expansion of the universe across billions of years. We infer its existence the way you might infer the wind by watching a field of grass bend. The grass is the galaxies, the bending is the acceleration, and the wind is this invisible majority of reality that we have named but not understood. There is a humbling number that captures how strange this is. When physicists try to calculate, from their best theories of the quantum vacuum, how much energy empty space should contain, they get an answer that is wrong, not by a little, but by an amount so enormous it has been called the worst prediction in the history of physics. The theoretical value is larger than the observed value by a factor with roughly 120 zeros after it. That is not a small disagreement. That is the sound of physics telling us, loudly, that we do not understand the thing that makes up most of the universe. We know it is there. We know what it does. We cannot explain why it is as gentle as it is. And this is the ingredient whose behavior decides the fate of everything. A thing we cannot see, cannot explain, and can only measure by its shadow on the expansion of the cosmos. A pressure in the emptiness, a push in the nothing. When you sit quietly tonight in a still room, the space around you is not truly still. It is faintly, patiently trying to expand, held in check on small scales by the gravity of the matter around you, but winning, everywhere, on the largest scales there are. So now we have our ingredient. We have the invisible majority, the pressure in empty space, the thing whose one defining number decides our fate. The next question is the one that turns this from a curiosity into a matter of survival for everything that exists. If dark energy governs the ending, then how many endings are there? What are the actual ways the universe can die? Because it turns out there are three, and they could hardly be more different from one another. There is a way to feel how precarious this all is, and it has to do with how recently we learned any of it. A person born in the middle of the 20th century grew up in a universe that was expected to slow down. The reasonable assumption, held by nearly every astronomer, was that the expansion begun in the Big Bang would gradually lose speed, braked by the gravity of all the matter pulling inward, and that the only real question was whether it would slow to a gentle halt or reverse into a collapse. Nobody, in that picture, needed a strange pushing energy in empty space. The universe was matter and gravity only pulls. Then the measurements of distant exploding stars arrived at the end of the 1990s, and the reasonable assumption simply broke. The far-off supernovae were dimmer than a decelerating universe could explain, which meant they were farther away than expected, which meant the expansion had not been slowing at all. It had been speeding up. And to make a universe speed up, you need something that pushes harder than all the matter pulls, something that does not thin away as gravity's grip should let it, something built into space itself. That was the moment the invisible majority announced itself. Not as a beautiful theory anyone had hoped for, but as an unwelcome fact the sky refused to take back. And the number W, the character of that fact, has been the quiet obsession of cosmology ever since, because the same discovery that revealed dark energy also revealed that we had no idea what it was, and that its behavior would decide everything. Part 3. The three ways it can end. The universe does not have one ending, it has at least three, and which one is true depends entirely on the ingredient we just met. This is something that almost never comes across in the way people talk about the end of everything. We speak of the end of the universe as if it were a single settled fact, a known destination, the way we speak of the sun eventually swelling into a red giant. But there is no single agreed ending. There are competing futures, and they are not minor variations on a theme. They are as different from one another as a candle guttering out is different from a building collapsing, is different from a sheet of paper being torn in half. And the reason there are three, rather than one, is that they correspond to the three things that number W can do. It can sit above -1, on -1, or below it. Three behaviors of dark energy. Three fates for reality. Let me lay them out, because we are going to spend the rest of tonight inside the third one, and you cannot feel the weight of it until you have seen what it is competing against. The first ending is the one most physicists expect, and it is called the heat death. This is the fate of a universe where dark energy is the steady cosmological constant, with W resting exactly on -1, or the gentle quintessence, with W just above it. In this future, the universe simply keeps expanding, faster and faster, and everything slowly runs down. The stars burn through their fuel over the next trillions of years. New stars stop forming once the gas runs out. The galaxies, one by one, exhaust themselves and fade to embers. Over spans of time so long that our ordinary words for large numbers become useless, matter itself may decay, and the black holes that remain slowly evaporate away through a faint quantum glow, until after something like a 1, followed by 100 zeros of years, there is nothing left but a thin, cold, formless haze, spread through an ever emptier space, every part of it drifting further from every other part forever. Nothing is destroyed violently. The universe does not break. It simply exhausts itself, like a fire that has burned all its wood and settles into cold ash. It is an ending by depletion. It is quiet, and it is very, very slow. The second ending is the mirror image of the first, and it is called the Big Crunch. Imagine that instead of pushing the universe apart forever, dark energy one day weakened, or reversed, or that gravity somehow regained the upper hand. Then the expansion we see today would eventually slow, stop, and turn around. Everything that has been flying apart since the Big Bang would begin to fall back together. Galaxies would approach one another instead of receding. The cosmic background would grow hotter instead of colder. And in the final stages, all the matter and energy of the universe would be crushed back into a single searing point. The Big Bang run in reverse, a collapse into fire. Current measurements make a simple version of this ending unlikely, because the universe appears to be extremely flat, and the expansion is clearly accelerating, not slowing. But a sufficiently strange, dynamic dark energy could in principle bring some form of it back. It is the ending of collapse, of everything falling home, of the cosmos crushing itself shut. And then there is the third ending, the one we are here for. If dark energy is not steady, and not fading, but growing, if that number W has slipped below -1, into the regime physicists call phantom, then neither slow exhaustion nor collapse awaits. Instead, the expansion runs away with itself. It gets faster and faster, not over trillions of years, but building toward a specific moment, a finite date in the future, at which the expansion becomes not just fast but infinite. And in the approach to that moment, the accelerating expansion reaches down through every scale of structure in the universe and pulls it apart. First, the great clusters of galaxies, then individual galaxies, then solar systems, then planets, then, in the final fractions of a second, atoms and the nuclei inside them. The universe does not cool into darkness, and it does not collapse into fire. It is torn to pieces while it is still full of working stars and living light. This is the Big Rip. Sit with how different these three are. In the heat death, structure survives, but loses all its energy. Galaxies and atoms remain, but nothing can ever happen in them again. In the Big Crunch, everything is pulled together and crushed. In the Big Rip, everything is pulled apart while still burning. The heat death preserves the pieces and drains the life. The crunch gathers the pieces and destroys them together. The rip scatters the pieces, one scale at a time. 3 endings, and the only thing that decides between them is the behavior of an invisible pressure in empty space that we have never been able to explain. And here is the detail that should keep you listening, the reason the Big Rip is uniquely unsettling among the three. The heat death and the Big Crunch are, in a sense, endings about time, about what happens after unimaginable stretches of it. But the Big Rip is an ending about the present. Its entire possibility rests not on some far future event, but on a property of the vacuum right now, in this room, tonight. Whether the number W is, at this very moment, sitting below -1. If it is, the clock is already running. The rip is not something that might begin in the far future. It is a process whose seed is already present in every cubic meter of empty space around you, waiting, in this scenario, to grow. So let us go and meet the phantom directly. Let us understand the one property of dark energy that turns a gentle push into a cosmic execution, the property that makes the emptiness grow stronger the more of it there is. Because once you understand that single reversal of intuition, everything about the Big Rip follows from it, inevitably, all the way down to the last atom. It helps to sit for a moment with just how gentle this pressure is today, because that gentleness is exactly why the phantom scenario is so treacherous. The push of dark energy is utterly negligible on any human scale, and even on the scale of a galaxy, it is completely overwhelmed by gravity. Two galaxies locked in orbit around each other do not drift apart. A solar system does not loosen. A planet does not swell. On every scale where matter is gathered closely enough to matter, gravity wins by a margin so enormous that dark energy might as well not exist. This is why the expansion of the universe does not stretch the ruler in your hand or widen the room you are in. Bound things stay bound. But that reassurance holds only as long as the number do behaves. In the tame case, dark energy stays a fixed, feeble background, forever too weak to touch anything that gravity holds together, and the bound structures of the universe survive to the cold end. In the phantom case, that same feeble background does not stay feeble. It grows, silently, at every scale at once, and the margin by which gravity wins begins, ever so slowly, to shrink. For a long time, nothing seems to change, because the push is still tiny, and then, near the end, it is not tiny anymore. The comfort of today, that the expansion cannot reach into the things you love and pull them apart, is a comfort that depends entirely on which side of -1 the number rests. Tonight it cannot touch you. In the phantom scenario, that is only because it has not yet grown strong enough. Notice, as we set these three endings side by side, that they are not really three separate theories competing for our belief. They are three branches of the same theory, and which branch the universe takes is decided by a single fork in the road. Start with what we actually observe today, an expanding universe, dominated by dark energy, accelerating outward, and then ask only one further question. What will dark energy do over the ages to come? Hold steady, and you walk the road to heat death. Weaken enough, and you might curve back toward a collapse. Strengthen without limit, and you race toward the rip. The same present, three futures, one fork. And the signpost at that fork is the value of W. This is why cosmologists care so intensely about measuring one seemingly obscure number. It is not obscure at all. It is the signpost that tells us which of the three roads the universe is already traveling. Part 4. The Phantom. Everything in the universe gets weaker as you spread it out. Everything, that is, except one thing, and that one thing is what would end us. This is the reversal at the center of the whole story, and I want to build it slowly, because it is genuinely difficult to believe the first time you meet it. Think about how ordinary substances behave when space expands. Take a box of gas and make the box bigger, and the gas gets thinner. The same amount of stuff spread through more room, so the density falls. Every familiar form of matter does this. Double the volume of the universe, and ordinary matter drops to half its density. Radiation, the energy of light, does even worse, because expansion not only spreads the photons out, but stretches each one to a longer, weaker wavelength, draining its energy as it goes. This is the intuition you carry with you everywhere, without ever thinking about it. Spread something out, and it thins, it weakens, it fades. More space means less of everything, everywhere. Now consider the cosmological constant, the tame form of dark energy, the one with W, exactly at -1. It does something already slightly unsettling. When space expands, its density does not fall at all. Every new cubic meter of space carries exactly as much dark energy as the old ones. So as the universe grows, the total amount of dark energy grows with it, because there is more space to hold it, but the density, the amount per unit volume, stays constant. This is already a strange substance. one that refuses to thin out. It is the reason a universe with a cosmological constant expands faster and faster. As matter dilutes away to nothing, this steady dark energy remains, and its relentless push comes to dominate. But at least it holds steady. At least it does not grow denser. And now we come to the phantom, and to the sentence that should make the back of your neck prickle. If the number W is less than -1, then when space expands, the density of dark energy does not fall, and it does not stay constant. It rises. There is more dark energy per cubic meter in a larger universe than there was in a smaller one. Expansion does not dilute this thing. It concentrates it. The more room space is given, the stronger the push in every part of it becomes. Take a moment to feel how wrong that is, how completely it inverts everything else in nature. Imagine pouring a single drop of ink into a glass of water and watching it spread, and instead of thinning to a pale tint, it grows darker as it spreads, more concentrated in every part of the glass, even as it fills more of it. Imagine a sound that grew louder the farther it traveled from its source. Imagine a fire that burned hotter the more you spread its embers apart. None of these things happen in the world you know, but this is precisely what phantom dark energy would do to the emptiness of space. Its defining trait is that dilution makes it stronger. And once you see that, the runaway becomes inevitable, and you can follow the logic yourself. Phantom dark energy pushes space to expand. That expansion, instead of weakening the dark energy, as it would weaken anything else, makes it denser. Denser dark energy pushes harder. Harder pushing means faster expansion. Faster expansion means still more space, which means still denser dark energy, which means still harder pushing. It is a loop that feeds itself, and unlike almost every other process in physics, it has no natural break, no built-in ceiling, no point at which it settles down. It accelerates without limit, and a process that accelerates without limit does not take forever to reach infinity. It reaches it in a finite amount of time. The name phantom was chosen deliberately, and it carries a warning. It was coined by the physicist Robert Caldwell in a paper published in 2002, and he chose it in part because this form of dark energy has a ghostly, forbidden quality. It violates conditions that physicists had long assumed any real form of energy must obey. We will come back to how forbidden it may truly be, because that is one of the few sources of hope in this whole picture. But for now, hold on to the physical fact, stripped of the mathematics. Phantom energy is a pressure in empty space that grows stronger as space grows larger, and therefore drives the expansion of the universe to become infinite at a specific moment in the future. Notice, again, that we have not left the thread. This entire runaway depends on one thing and one thing only, whether W is below -1. If it is exactly -1, the density holds steady, and you get the heat death, fast expansion, but no runaway, no infinite point, no rip. If it is above -1, the density falls, gently, and the ending is softer still. It is only when the number crosses below -1, into phantom territory, that the loop ignites. Everything hinges, still, on the sign of that one quantity, on which side of the line the emptiness in this room truly sits. We have now met the engine. We understand the strange, backward substance that could tear the universe apart, a dark energy that fattens on the very expansion it creates. What we have not yet done is confront the most disturbing consequence of that engine, the thing that makes the Big Rip unlike any other ending anyone has imagined. It is not merely that the universe is destroyed, it is that the destruction arrives on a schedule, with a final date, a countdown that can, in principle, be written down. Let us look at what it means for the universe to have not just an ending, but a deadline. I want to add one more layer to how strange this substance is, because the reversal goes even further than it first appears. For ordinary matter, energy and gravity behave the way your intuition expects. Mass pulls, energy dilutes, and spreading things out weakens their effect. Even light, the most ethereal thing we know, loses energy as the universe stretches it. Everything in the familiar catalogue of the cosmos gets fainter with expansion. So when physicists first wrote down a form of energy whose density climbs as space grows, many assumed it must be a mathematical mistake, an artifact that would vanish under closer examination. It did not vanish. It sits there in the equations as a perfectly consistent possibility, forbidden by no law we can point to with certainty, waiting to be either ruled out or confirmed. And the reason it is so hard to rule out is that, from where we stand, phantom energy and the tame cosmological constant look almost identical today. Both push the universe to expand faster, both are invisible, both are spread smoothly through space. The only difference is what they will do over the coming billions of years, whether the density holds steady or creeps upward. Distinguishing between them requires measuring not just how fast the universe expands, but how that expansion rate is itself changing over cosmic time, which is one of the most delicate measurements in all of science. We are trying to catch a number in the act of drifting, using light that left its sources billions of years ago. That is why the question remains open. The phantom does not announce itself. It hides inside a value that looks, for now, almost exactly like the safe one. Part 5. An ending with a finish line. Most ways the universe could end have no last moment. The Big Rip does. A specific instant, after which there is simply no more time to speak of. This is what sets the Big Rip apart from every other cosmic fate, and it is worth pausing on, because it is a genuinely alien idea. When we talk about the heat death, we never talk about a final moment. There is no last second of the heat death. It approaches its cold, empty state asymptotically, getting ever closer, but never quite arriving, stretching on toward infinity. You can always ask what happens next, and there is always a next. The universe simply grows colder and emptier, without end. But the Big Rip is different in the most fundamental way possible. It has a finish line. There is a specific future time. Physicists write it as T-Rip, the time of the rip, at which the mathematics that describes the size of the universe returns not a large number, but infinity. And after that moment, the equations do not describe anything at all. There is no next. The story does not continue past the final page. It simply stops. Let me explain what it means for the size of space to become infinite in finite time, because this is the strange mathematical core of the whole scenario. Cosmologists describe the expansion of the universe with a quantity called the scale factor. You do not need the symbol, you need the idea. The scale factor is just a measure of how stretched space is, how far apart 2 points that are not otherwise moving would drift simply because the space between them is growing. Today, the scale factor is increasing steadily, and in a heat-death universe, it would go on increasing forever, growing larger and larger toward infinity, but taking an infinite amount of time to get there. In the phantom universe, because of the runaway we just described, the scale factor does something no ordinary growing quantity does. It races upward faster and faster, and it reaches infinity at a particular finite time. The stretching of space does not merely become very large. It becomes unbounded, complete, total, and it does so on a date you could in principle circle on a calendar. When space itself becomes infinitely stretched, every distance between every pair of points becomes infinite at once. That is the rip. It is not an explosion that travels outward from some center. It is not a wave that sweeps across the sky. It happens everywhere, simultaneously, because it is a property of space as a whole, not an event within space. In the final instant, the distance between any two things, two galaxies, two atoms, the two ends of a single particle, is driven to infinity together. That is why there is no after. There is no space left in any usable sense, no distances that mean anything, no framework in which a next moment could occur. So how far away is this finish line, if it exists at all? This is where the equations give us something almost tangible. The time until the rip depends on how far below -1 the number W has slipped, and on how fast the universe is currently expanding. The further below -1 the number sits, the more violent the runaway, and the sooner the rip. The closer the number sits to -1, the gentler the approach, and the later the rip, or never, if the number is exactly on the line. In the original paper that worked all this out, published in 2003 by Robert Caldwell, Mark Kamiankowski, and Nevin Weinberg, the authors chose an illustrative value to show what the numbers looked like. They set the number W to -1.5, well into phantom territory, and with the expansion rate and matter content we observe, they calculated the time to the rip. The answer was about 22 billion years from now. Let me put that number in some human context, because on its own it is just a figure. The universe today is about 13.8 billion years old, so 22 billion years is more than the entire current age of everything, again, and then some. The sun will not last that long. In a few billion years, it will swell and die, and the earth with it, long before any rip. So in this particular example, the big rip is not a near thing. It is far off in a future that neither we, nor the sun, nor the earth will ever see. But that is only for the value they chose to illustrate with. Pick a number W closer to -1, and the rip moves much further out, tens or hundreds of billions of years, or off the table entirely. Pick a number further below -1, and it rushes closer. The date is not fixed, it is a dial, and the dial is set by exactly how phantom the dark energy is, by exactly where that one number sits. And here is the thing I want you to carry into what comes next. Even at 22 billion years, even at 100 billion years, the character of this ending is unlike any other, because it is scheduled. Somewhere out in time, in this scenario, there is a specific moment when everything comes apart. And the approach to that moment is not gentle and uniform. It is a countdown, one that begins slowly, with the largest structures in the cosmos, billions of years before the end, and then accelerates, faster and faster, compressing the destruction of ever smaller things into ever shorter intervals, until the final unmaking of an atom takes less time than any moment you have ever noticed. The universe would come apart the way it was built, but in reverse, and on a clock. That countdown is the most haunting part of the entire idea, and it is where we go next, because the order in which things are torn apart is not random. It follows a strict and beautiful and terrible logic, a logic written by how tightly each thing in the universe is bound together. And once you understand that logic, you can watch the end approach, structure by structure, and know exactly what comes apart next. It is worth being precise about what a future singularity actually means, because the word can sound like mysticism when it is really just mathematics reaching the end of what it can describe. A singularity, in this sense, is simply a point where a quantity our equations track becomes infinite, and where those equations therefore stop giving sensible answers. We meet the same idea at the center of a black hole, where the curvature of spacetime is calculated to blow up. In the Big Rip, the quantity that runs to infinity is the size of space itself, and the moment it does, every distance-based description of the universe loses meaning at once. It is not that something dramatic happens and then the universe continues in some altered form. It is that the framework we use to say what happens no longer has anything to stand on. This is part of why physicists are cautious about the Big Rip, even when they take it seriously. A finite time singularity is often a sign that a theory has been pushed past its limits, that some piece of physics we have left out would step in before the true infinity arrived. Perhaps quantum effects, or some unknown behavior of dark energy near the end, would soften the runaway and prevent the final tearing. We do not know. What we can say is that within the equations as written, taken at face value, the phantom universe genuinely does reach a last moment, a real edge to time. not an endless fading, but a hard stop. And whether that edge is a true feature of reality or a warning that our equations have failed, it exists only if the number w has crossed below -1. Without the phantom, there is no finish line at all. There is something worth pausing on in the fact that the date of the rip is a dial rather than a fixed appointment. It means the Big Rip is not a single prophecy, but a family of them. One for every possible value of w below -1. If dark energy is only barely phantom, sitting at -1.01, the rip lies so far in the future that the universe would grow old and dark, almost as if heading for heat death before the tearing ever arrived. If dark energy is aggressively phantom, well below -1, the rip could come far sooner in cosmic terms. The scenario does not commit to a time, it commits to a shape, a countdown that accelerates and ends in a singularity, and leaves the actual date to be set by exactly how far the number has strayed past the edge. This is why measuring where, precisely, is not an academic exercise. It would not only tell us whether the rip is coming, it would tell us when. Part 6. The Order of Unmaking. Everything comes apart in the order it was built. The loosest things first, the tightest things last, in a sequence you can read like a countdown. This is the logic at the center of the Big Rip, and it is what turns the scenario from a vague catastrophe into something almost unbearably specific. The universe is a hierarchy of structures, held together by forces, and each structure is bound with a certain strength. Galaxy clusters are held together by gravity, but only weakly, because their parts are enormous distances apart, and the pull between them is gentle. Individual galaxies are held more tightly, their stars bound in orbits by the collective gravity of the whole. Solar systems are bound more tightly still, planets gripped firmly by the gravity of their star. Planets themselves are held together by their own gravity, pulling every part toward the center, and atoms are bound not by gravity at all, but by the electromagnetic force, which on the scale of an atom is staggeringly stronger than gravity, and the nuclei inside atoms are held by the strong nuclear force, stronger yet, the tightest grip in all of nature. Now recall what phantom dark energy does. As the rip approaches, the density of dark energy within any region of space grows without limit. And that means the outward push of dark energy inside any given structure, inside a cluster, inside a galaxy, inside a solar system, inside an atom, also grows without limit. A structure survives only as long as the force holding it together is stronger than the outward push of the dark energy inside it. The moment the growing dark energy push exceeds the binding force of a structure, that structure comes apart. There is no gradual fraying, no partial damage. There is a threshold, and when the push crosses it, the thing is undone. You can see immediately why the order is fixed. The most loosely bound structures have the lowest threshold, so they are the first to be overwhelmed as the dark energy push climbs. The most tightly bound structures have the highest threshold, so they hold out the longest. The dark energy grows steadily stronger everywhere, and one by one, it crosses the binding strength of each level of structure, from the weakest grip to the strongest. Galaxy clusters, bound most loosely, dissolve first, then galaxies, then solar systems, then planets, then atoms, then, last of all, the nuclei at the centers of atoms, held by the strongest force nature has. The universe is disassembled in the exact reverse of the order in which its structures are ranked by strength, the faintest bonds broken first, the fiercest bonds broken last. And there is a second feature of this countdown that is even stranger than its order, and it is the thing that gives the Big Rip its peculiar horror. The intervals between the stages are not equal, they shrink. The gap between the destruction of galaxy clusters and the destruction of individual galaxies is enormous, on the order of 1 billion years in the illustrative case. The gap between the destruction of galaxies and the unbinding of solar systems is much smaller, tens of millions of years. The gap between the unbinding of the solar system and the destruction of a planet is smaller still, a matter of months. And the final stages, the tearing of atoms and then of nuclei, are separated from the destruction of the planet by mere minutes, and from each other by spans of time so short that no human sense could register them, small fractions of a single second. The countdown does not tick evenly toward zero. It races. It compresses. Each stage arrives faster than the one before, until at the very end the destruction of the smallest, most tightly bound things happens almost instantaneously. Why does the countdown speed up? It is a direct consequence of the runaway we have been building toward all night. The dark energy density is not climbing at a steady rate. It is climbing faster and faster as the rip approaches, because of that self-feeding loop where expansion breeds more dark energy, which breeds more expansion. So the push blows through the lower thresholds slowly at first, when the dark energy is still relatively weak, and then tears through the higher thresholds in a rush at the end, when the dark energy has become almost infinitely strong. The tightest bonds in the universe, the ones that held out the longest, are broken in the final blink, because by then, the force breaking them has grown beyond all bound. I want you to hold this picture clearly, because we are about to live through it, stage by stage, and the shape of it matters. Picture a countdown clock, but a distorted one, where the early numbers take billions of years to pass, and the final numbers flick by faster than thought. The first mark on that clock is the dissolving of the great clusters of galaxies, a billion years before the end, and from there, each mark comes quicker than the last. The galaxies, the sun and its planets, the earth, the atoms, the nuclei, the whole architecture of the cosmos, undone from the outside in, from the loosest to the tightest, on an accelerating clock that ends in a single, final, infinite instant. And through all of it, the same quiet fact remains true, the fact we started with. None of this happens because of a force reaching in from somewhere. It happens because the empty space woven through every one of these structures, the space between the galaxies, the space between the sun and its worlds, the space between an electron and its nucleus, grows and grows until it outruns whatever was holding those things together. It is the emptiness itself that unbuilds the universe. And so let us begin the countdown where it truly begins, not with atoms, not with the earth, but with the largest structures that exist, a billion years before the end, when the first thing an observer would notice is not a violence at all, but an absence, the slow, silent emptying of the night sky. There is a quiet beauty hidden inside this terrible order, and it is worth naming before we live through it. The sequence of destruction is a perfect mirror of the sequence of creation. The universe did not assemble itself all at once. It built structure over billions of years, gravity gathering matter into the first stars, stars into galaxies, galaxies into groups and clusters, and the great cosmic web, each level of structure a little more loosely held than the one below it. The largest structures, the superclusters, are the youngest and the most fragile, bound by the faintest threads of gravity across the greatest distances. The smallest structures, the atoms and their nuclei, are the oldest and the fiercest, forged in the first minutes and the burning cores of stars, held by the strongest forces nature commands. So when the big rip runs its course, it is not merely destroying the universe, it is reading the universe's history backward. It unbuilds in the exact reverse of the order in which things were built, undoing the youngest and weakest bonds first, and the oldest and strongest bonds last. The cosmic web dissolves before the galaxies before the stars and their worlds, the worlds before the atoms before the nuclei that were among the very first structures to exist. It is as though a film of all cosmic history were played in reverse and sped up, the whole patient labor of billions of years of gathering undone in a countdown that starts slow and ends faster than thought. Everything comes apart in the order it was built. Hold that sentence, because you are about to watch it happen, one scale at a time. It is also worth noticing that the forces doing the holding, all along, are the same forces that govern your ordinary life. Gravity keeps you in your chair and holds the clusters together. Electromagnetism binds your molecules and holds the electrons to their atoms. The strong nuclear force locks the nuclei that make up every atom of your body and every atom of the world. These are not exotic cosmic powers reserved for the end of time. They are the everyday forces of matter, the ones that make solid things solid and keep the universe from being a formless mist. The Big Rip is, in a sense, simply the story of dark energy growing strong enough to overpower each of these familiar forces in turn. First the weakest, gravity across the largest distances, and finally the strongest, the nuclear grip at the center of the atom. Nothing new is invented to do the tearing. The tearing is just the moment when the oldest, most ordinary bonds in nature finally meet a push they cannot answer. Part 7. The last billion years, the sky empties. Imagine standing under a night sky in the last billion years before the end. At first, nothing seems wrong, and that is the most unsettling part. The stars overhead still shine. The band of our own galaxy, the Milky Way, still arches across the darkness, its billions of stars still bound together, still turning slowly in their great wheel. If you did not know what was coming, you might look up and see a sky that looked much like the one above you tonight. But an astronomer in that age, someone with instruments and long records, would notice something that no casual observer would catch. The faint smudges of light that we call other galaxies, the distant islands of stars that fill our telescopes today, the thousands upon thousands of them scattered across every patch of sky, would be disappearing, not exploding, not dimming in any dramatic way, simply sliding away, receding faster and faster, their light stretched and weakened by the accelerating expansion, until one by one they cross a threshold beyond which their light can no longer reach us at all, and they wink out of the observable universe entirely. Let me take you there, because this is a moment worth inhabiting rather than merely describing. You are standing on a world beneath that sky, in the last billion years. The air is still, the ground is solid. Above you, the familiar stars of your own galaxy burn steady and calm. But you have brought with you a record, images of this same sky taken across the ages of your civilization. And when you compare them, you feel something cold settle in your chest. The faraway field, the part of the sky that once held countless distant galaxies, is going dark. A galaxy that your ancestors could see is no longer there. Another, fainter now than in the records from a mere 10 million years ago, is fading toward the same fate. The universe beyond your own galaxy is emptying, quietly, patiently, like a great house in which someone is walking from room to room, closing the windows one by one. There is no sound to it. There is no violence in it yet. There is only the slow, absolute loneliness of a cosmos withdrawing from you, each distant light slipping past the edge of the visible and never returning. And you understand, standing there, that this is not your galaxy dying. This is the rest of the universe leaving. That is the first stage of the rip, as it would actually be experienced, not a tearing at all, but a vanishing. The great clusters and superclusters of galaxies, the largest bound structures in existence, are being pulled apart by the growing dark energy, their members flung away from one another, and as they scatter and recede, the sky beyond the Milky Way goes dark. This happens roughly a billion years before the final moment, in the illustrative timeline. It is slow by human standards, unfolding across millions of years, but on the scale of cosmic history, it is the beginning of the end, the first threshold crossed, the loosest bonds in the universe, finally overwhelmed. And then the process comes closer to home. Having dissolved the clusters, the growing dark energy turns, in effect, to the galaxies themselves. Our Milky Way holds its hundreds of billions of stars together by their collective gravity, each star tracing a slow orbit around the galactic center, the whole enormous wheel bound into one system. But as the dark energy push climbs, it begins to exceed even that binding. In the illustrative timeline, about 60 million years before the end, the galaxy comes undone. The stars, no longer held in their orbits, drift apart. The great spiral structure loosens and disperses. The wheel that has turned for more than 10 billion years stops being a wheel and becomes a scattering of isolated stars, each one flung onto its own lonely path through an expanding emptiness, each one receding from all the others. Notice how the countdown has already tightened. The clusters dissolved a billion years before the end. The galaxy comes apart only 60 million years before it. The interval has shrunk by more than a factor of 10. The clock is speeding up, exactly as the runaway demands. And notice, too, that we have not yet felt anything on a human scale. 60 million years before the end, the Sun, if it still existed in such a scenario, would still hold its planets. A world would still orbit its star. The catastrophe, for all its cosmic scale, has not yet reached down to the size of a solar system. But it is coming, and now it is coming quickly, because the dark energy is stronger than it has ever been, and growing stronger by the moment. I want to leave you, at the close of this stage, with the strangeness of that emptying sky, because it overturns something we assume without thinking. We imagine the end of the universe as a crowded, violent thing, fire, collision, spectacle. But the first thing the Big Rip would actually bring is the opposite, solitude. A sky going quiet and dark and empty, one light at a time. The violence comes later, and it comes fast. But it begins with an absence so gentle you could almost miss it. The universe, in its final billion years, slowly and silently closing its windows against you. And the next window to close is the one closest to any living thing, the bond between a star and the worlds that circle it. Let us follow the countdown inward to the last 3 months, when the sun itself begins to lose its grip. Before we leave this emptying sky, I want you to feel one more thing about it, because it changes the meaning of loneliness itself. The galaxies that slide away and vanish are not destroyed in this first stage. They still exist. Somewhere out there, beyond the reach of any possible signal, those other islands of stars go on burning, unaware, each one now cut off from all the others by an expansion that has carried them past the point where light can ever bridge the gap again. It is not that the universe grows smaller, it is that every part of it becomes an island, sealed off, alone, no longer able to send or receive so much as a single photon from any other part. An observer in that late age would face a strange and total isolation, one no earlier astronomer could have imagined. The records handed down from ancient times would speak of a sky full of galaxies, a universe teeming with other worlds of stars. But looking up, that observer would find those galaxies gone, the outer darkness swept clean, the only remaining light, the stars of their own scattering galaxy, and, soon, not even all of those. The universe would seem to be shrinking around them, closing in, when in truth, it was expanding faster than ever. The cruel paradox of the phantom end, where the more violently everything flies apart, the smaller and lonelier the visible world becomes. And that is only the beginning. The isolation of the emptying sky is gentle compared to what follows, because next, the growing emptiness stops merely hiding the universe and starts taking it apart, beginning with the bond nearest to any living thing, a star, and the worlds that turn around it. Consider too what this stage does to the very idea of a shared universe. For all of human history, everyone who has ever looked up has seen, in principle, the same cosmos, the same distant galaxies, the same faint light from the same far-off places, a universe held in common by every observer within it. The emptying sky ends that. It severs the shared cosmos into countless isolated pockets. each one able to see only itself, each one's sky a different and shrinking thing. The universe would stop being one place that everyone inhabits and become a scatter of sealed rooms, and no messenger, no signal, no light could ever again pass between them. The loneliness of the phantom end is not only that things are pulled apart, it is that the very possibility of connection, of one part of the universe knowing another exists, is quietly extinguished, long before the final tearing begins. Part 8. The last 3 months. The sun lets go. 3 months before the end, the sun begins to let go of its planets. Not in fire, in silence, and in slow motion. We have followed the countdown from the largest structures inward. The clusters gone 1 billion years before the end. The galaxy scattered 60 million years before it. Now the growing dark energy reaches the scale of a single star and its family of worlds, a solar system like our own, and here the intervals have collapsed from millions of years to mere months. In the illustrative timeline, about 3 months before the final moment, a solar system becomes gravitationally unbound. The star can no longer hold its planets, and because I want you to feel this, rather than simply file it away as a fact, let me take you down to the surface of a world in those final months and let you watch it happen. You are standing on a planet, and above you is a sun. Not our sun necessarily, but a star with worlds around it. In the last season before the end, for your whole life, and for all the ages before you, that star has been the one fixed certainty of the sky. It has risen and set. It has anchored the year. It has held your world in a steady orbit, neither drifting away nor falling in, for billions of years. And now, over the course of a few weeks, that certainty begins, impossibly, to loosen. The star does not explode, it does not flare or darken in any dramatic way. Instead, it seems to shrink. Day by day, week by week, it grows a little smaller in the sky, a little fainter, a little cooler on your skin. Your world is drifting outward, away from its star, because the space between them is expanding faster than the star's gravity can pull the planet back. The orbit is unwinding. The tether is going slack. There is an eerie gentleness to it, and that gentleness is the thing that makes it so hard to bear. You keep waiting for a catastrophe, for a moment of violence, for something to strike, but nothing strikes. The star simply recedes, quietly, steadily, the way a boat drifts from a dock when the rope is untied. No jolt, no drama, just an ever-widening gap and the slow cooling of the light. The days grow colder. The star that warmed every moment of your world's history becomes a smaller and paler disk, and then a brilliant point, and you understand that it is not going out. It is letting go, the most reliable relationship in the entire sky. The bond between a world and its sun is dissolving not with a scream, but with a sigh, and there is nothing in the reach of any hand to stop it, because the thing pulling you apart is not a force you can push against. It is the growing of the emptiness itself. That is what it would mean for a solar system to come unbound. The planets do not crash. They wander off, each drifting outward into the dark on its own widening path, released from the star that held them, as the dark energy inside the system finally overwhelms the gentle grip of gravity across those planetary distances. And the timing tells you how close the end now is. The clusters went 1 billion years before the rip. The galaxy went 60 million years before. The solar system comes apart just 3 months before. From 1 billion years to 3 months, the countdown has compressed almost beyond recognition, and it is still accelerating. I want to draw out one more thread from this stage, because it connects back to something we said at the very beginning, and it deserves to be felt now, here, when a sun is releasing its worlds. We began by saying that empty space is not empty and not passive, that dark energy is a pressure built into the vacuum, faint and patient, held in check on small scales by the gravity of matter. On the scale of a solar system today, that push is utterly negligible. The The Sun's gravity wins by an overwhelming margin, which is why the Earth's orbit is stable and will remain so for billions of years, regardless of dark energy. But in the phantom scenario, the push does not stay negligible. It grows and grows, until the same faint pressure that today cannot budge a planet by the width of an atom becomes strong enough, in those final months, to pry a world loose from its star. The thing tearing the solar system apart is not new. It is the same quiet property of empty space that surrounds you right now. It has only grown, in this scenario, until the emptiness is stronger than the sun. And here is the part that should keep you awake, gently, at the edge of sleep. If a solar system comes apart 3 months before the end, then whatever remains of a planet within it has only those 3 months left, and the destruction does not stop at the scale of worlds. The dark energy is still growing. It has broken the bond between a star and its planets. Now it turns to the planets themselves, to the gravity that holds a single world together, to the ground and the rock and the core. The countdown that took 1 billion years to reach the clusters, and 60 million to reach the galaxy, and 3 months to reach the solar system, now needs only a matter of minutes to reach the next thing in its path. And the next thing in its path, in our own case, is the Earth. Let us go to the last half hour. There is a detail in this stage that makes it more haunting the longer you consider it, and it concerns how ordinary the physics remains right up to the end. Nothing exotic reaches into that solar system to tear it apart. There is no wave, no radiation, no cosmic weapon. The gravity of the star behaves exactly as it always has, following the same law it has obeyed for billions of years. The planets follow their orbits by the same rules they always did. The only thing that has changed is the emptiness between them, which has begun to expand faster than the star's familiar gravity can compensate for. Every individual piece of physics is completely normal. It is only their balance that has tipped, and once it tips, the same steady laws that built the orbit now let it unwind. That normality is the quietly terrifying part. We tend to imagine cosmic catastrophe as a violation of the natural order, a moment when the rules break down. But the Big Rip is the opposite. It is the rules working perfectly, obediently, all the way to the end. The star keeps pulling, with exactly the strength it should. The planet keeps responding exactly as it must. And the world drifts away into the cold, not because anything went wrong, but because the emptiness kept doing the one thing it has always done, expanding, until that ordinary expansion was simply larger than the ordinary pull. The reliable becomes the fatal without ever ceasing to be reliable. And once the star has released its planets, the same unbroken logic turns to the planets themselves, and the countdown that measured the death of a solar system in months now measures the death of a world in minutes. Part 9. The last 30 minutes. The ground opens. 30 minutes before the end, the Earth itself begins to come apart. This is no longer a distant galaxy or an abstract cluster. This is the ground beneath your feet. We have come a long way down the countdown, from the emptying sky to the loosening sun, and now the growing dark energy reaches the scale of a single planet, a world held together by its own gravity, every part of it pulled toward the center, the whole of it bound into one solid sphere. In the illustrative timeline, about 30 minutes before the final moment, that binding fails. And I want to slow down here, more than anywhere else tonight, because this is the stage where the abstraction of cosmic fate becomes something bodily, something you can feel in the soles of your feet, something that is not happening to the universe out there, but to the very floor beneath you. Consider what it means for a planet's self-gravity to be overwhelmed. The Earth holds together because every piece of it is pulled toward every other piece. All of that pull summing into a grip strong enough to compress rock and iron into a sphere and hold it firm for billions of years. That grip is what gives you the ground. It is what makes the floor solid, the mountains stable, The whole world a single, reliable thing that has never once, in all of human history, failed to be there beneath you. And in the last half hour before the rip, the dark energy inside the Earth, the outward push of the expanding space threaded through every part of it, grows stronger than that grip. The planet can no longer hold itself together against the expansion of the space inside it, and so it begins to come apart. Not struck from outside, but pulled apart from within, every part of it drifting away from every other part, as the space between them swells. Here is the realization I want you to sit with, the one that gives this moment its full weight. When we say the universe expands, it sounds like an abstract fact about distant galaxies, a statement in a textbook, something that happens far away and long ago. But in this scenario, the sentence "the universe expands" and the sentence "the ground beneath me is destroyed" become the same sentence. There is no difference between them. The expansion is not something that happens only in the gaps between galaxies. It is happening everywhere, in every cubic meter of space, including the space inside the rock you stand on, the space inside the walls around you, the space between the particles of the floor. Today, that expansion is so utterly overwhelmed by gravity on small scales that it has no effect at all. The Earth does not grow by even the width of a single atom because of cosmic expansion, because gravity holds it fast. But in the final 30 minutes of the phantom universe, gravity loses. And the same expansion that spent the whole history of the cosmos merely carrying galaxies apart, reaches down at last and opens the ground itself. There is something almost unthinkable in the ordinariness of the timescale. 30 minutes. Not 30 million years, not 30,000. 30 minutes, a span you have lived through countless times without a thought. The length of a walk, a meal, a quiet moment before sleep. In the phantom scenario, the entire destruction of a planet, from a whole and solid world to a dispersing cloud of matter, occupies that same familiar half hour. The countdown, which began with billions of years between its early stages, has now compressed the death of an entire world into the span of a single, ordinary interval, of a single, ordinary day. That is what it means for the clock to accelerate. That is what the runaway does at the end. It takes the unhurried patience of cosmic time and squeezes it, faster and faster, until the unmaking of a planet happens in the time it takes to notice it is happening. And I want to be careful and honest here, because this is a place where the science asks for both feeling and precision. The Big Rip, in this illustrative form, is not a prediction that the Earth will be destroyed in 30 minutes at some known date. It is a scenario, a consequence that follows if dark energy is phantom, worked out to show what such a universe would do. The Earth, in reality, will be gone long before any rip, consumed by the sun's old age, billions of years from now. What the 30-minute figure gives us is not a forecast for our planet, but a way to feel the shape of the ending, to understand that if the phantom scenario is true, then the same expansion we measure today, the same push in the same empty space, would in its final moments reach the scale of a world and pull it open in half an hour. The horror is not that it is scheduled for us. The horror is that it is written into the very space we are made of, waiting on the value of a number. So let us follow the countdown to its final stage, because there is one more threshold below the planet, and it is the strongest and tightest bond in all of nature. Below the scale of worlds lies the scale of atoms, and below atoms, the nuclei at their centers, held by the strongest force that exists. The dark energy has broken every gentler bond on its way down. Now, in the last fraction of a second, it comes for the atom, and for the tiny, fierce knot of the nucleus, the last thing in the universe to let go. Let me add one more turn to this, because it reaches past the planet and touches the body directly, and it is the truest way to understand what the Big Rip would mean. Your own body is a bound structure. The atoms that make you are held in place relative to one another by chemical bonds. which are electromagnetic, and those bonds are what keep you a single coherent thing rather than a drifting cloud of particles. In the ordinary universe, cosmic expansion has no effect on you whatsoever. The forces holding your molecules together are unimaginably stronger than any push from dark energy, and they will remain so under the tame ending forever. You are safe from the expansion of the universe in the same way the Earth is safe, by an overwhelming margin. But that margin, again, is only overwhelming as long as the number w behaves. In the final moments of the phantom scenario, after the ground has opened and the planet has dispersed, the growing dark energy would come for the bonds that hold a body together, as surely as it came for the bonds that hold a world together. There is no special protection for living things, no scale at which the rip politely stops. The same expansion, grown strong enough, would separate the molecules of any remaining matter, including the molecules that had once been part of something alive. It is a strange and sobering thought that the emptiness you cannot even feel tonight, the nothing between your own atoms, is the very thing that would, in this scenario, one day undo you. Not a fire, not a flood, not a collision. The quiet space you are made of, grown at last into something that could not be held. And below the molecule and the atom lies one final threshold, the tightest knot in all of nature, and it is there that the countdown ends. And here is perhaps the strangest comfort and discomfort of it together. Nothing about this would hurt in the way we imagine catastrophe hurting, because there would be no time, at the end, for anything to register. The final unmaking of matter happens faster than any nerve can carry a signal, faster than any thought can form. Whatever the last 30 minutes of a world would be, the true end of it, the tearing of the atoms themselves, would arrive and be complete before awareness could even begin to respond. There is a kind of mercy hidden in the cruelty of the accelerating clock. The very speed that makes the ending so total also makes it, in its final instant, imperceptible. The universe would not linger over its own dismantling. It would simply, at the last, be finished, in less time than it takes to notice that anything had changed at all. Part 10. The last fraction of a second. Atoms. The last thing in the universe to come apart is the atom, and it happens in less time than any moment you have ever known. We have followed the countdown all the way down, the sky emptying over 1 billion years, the sun releasing its worlds 3 months before the end, the earth opening in the last 30 minutes. And now we arrive at the final threshold, the smallest and the tightest, the bond that holds together the very stuff of matter. An atom is held together not by gravity, which on this scale is almost nothing, but by the electromagnetic force, which binds the electrons to the nucleus with a grip that, relative to the size of the thing, is staggeringly strong. And further inside the nucleus, the protons and neutrons are held by the strong nuclear force, the most powerful force in all of nature, the tightest knot the universe can tie. These are the last things standing. Every looser structure has already been undone, and in the final fraction of a second before the rip, the growing dark energy, now almost infinitely strong, reaches even these. Let me take you to that final instant, down at the scale of a single atom, because it is the strangest and most intimate moment in the whole story. Picture one atom, at its center, a nucleus. Around it, an electron, held in its place by the electromagnetic force, a force that has never once, in the entire history of the universe, let that electron go. For 13 billion years and more, across every process the atom has ever been part of, through the forging of the element in a star, and its scattering into space, and its gathering into a world, that bond has held. It is one of the most reliable things in all of existence. And now, in the last sliver of a second, the space between the electron and the nucleus begins to grow faster than the force can pull it back. The electron slides outward. The bond that never broke, breaks. And an instant later, a span of time so short that the interval between the atom coming apart and the nucleus coming apart is a tiny fraction of a single second. The nucleus itself, held by the strongest force nature has, is pulled apart too. Its protons and neutrons flung away from one another as the space between them becomes infinite. And then the scale factor reaches its limit. Every distance becomes infinite at once. And the mathematics that has described the universe from its first moment simply ends. There is no next instant. The story stops mid-sentence because there is no longer any space in which a next sentence could be written. Sit with the time scale of that final stage because it is almost impossible to hold. The destruction of the atom and its nucleus occupies something on the order of a 10 billion billionth of a second, a length of time so short that no human sense, no nerve, no thought could ever register it. Compare that to where the countdown began, a billion years between the dissolving of the clusters and the scattering of the galaxy. The clock has gone from billions of years between its stages to a fraction of a single second, all because of the runaway, the self-feeding growth of dark energy that becomes almost infinitely fast at the very end. The tightest bonds in the universe, the ones that held out the longest, are broken in an instant too brief to imagine, because by then the force breaking them has grown beyond all limit. And here, at the smallest scale, the thread we have carried all night ties itself off, because everything really does come apart in the order it was built. The universe assembled itself from the bottom up and the top down over billions of years. Particles into atoms, atoms into worlds and stars, stars into galaxies, galaxies into clusters. And the Big Rip undoes that assembly in reverse of binding strength. The loosest bonds first and the tightest last. Clusters, then galaxies, then solar systems, then planets, then atoms, then nuclei. The faint gravitational grip of a supercluster gave way a billion years before the end. The fierce nuclear grip of a single atomic nucleus holds until the final 10 billion billionth of a second. The whole architecture of the cosmos, taken apart from the outside in, from the weakest to the strongest, on an accelerating clock that ends in one infinite instant. Everything comes apart in the order it was built. There is a quiet vertigo in realizing that the same growing emptiness performs every stage of this. It is not that different forces destroy the clusters and the galaxies and the atoms. It is one thing, the same expanding space, the same dark energy, reaching every scale in turn as it grows. The push that pried apart the superclusters and the push that pries apart the last atom are the same push, only stronger, and it was present all along, in every cubic meter, faint and patient, held down by gravity and electromagnetism and the nuclear force, until, one by one, in order, it outgrew them all. Now, I have taken you all the way to the end of the universe, to the final instant, to the tearing of the last atom, and I have done it as though we knew this were coming. But we do not. And this is where the story turns, where the terror opens into something more uncertain and, in a strange way, more interesting. Because the Big Rip may not be possible at all. The very substance required to produce it, the phantom energy, the dark energy that grows as it dilutes, may be forbidden by the laws of physics for reasons we are only beginning to understand. The ending we have just lived through may be a mathematical possibility that nature does not allow. Let us look at why the phantom may be a phantom in more ways than one, why the thing that would end us may not be able to exist. I want to linger for one more moment on the sheer compression of that final instant, because it is the feature that most defies imagination, more even than the infinity at the end. Think again about the span of the whole countdown. The dissolving of the great clusters happens roughly a billion years before the end. The scattering of the galaxy, about 60 million years before. The unbinding of the solar system, about 3 months before. The tearing of the planet, about 30 minutes before. and the tearing of the atom and its nucleus less than a 10 billion billionth of a second before. Lay those intervals side by side, and you see a countdown collapsing toward zero at a rate that has no parallel in ordinary experience. Billions of years, then millions, then months, then minutes, then a fraction of a heartbeat so small it has no name in common speech. That collapse of the intervals is the signature of the runaway, the visible fingerprint of a force that strengthens without limit. A steady process ticks evenly. A runaway process ticks faster and faster, cramming more and more into less and less time, until at the very end it does an infinite amount in a finite instant. And so the last stages of the universe, in this scenario, would unfold in a rush so steep that the destruction of everything smaller than a planet, every atom, every nucleus, all the fine structure of matter built up over the entire history of the cosmos, would be finished in less time than it takes a single nerve to fire. The universe would spend billions of years dismantling its largest structures and then undo all its smallest ones in an eye blink. And after that eye blink, nothing. No space, no time, no next. Which is exactly the point at which we should stop and ask the question that changes everything, whether any of this is truly allowed to happen at all. Part 11. The Forbidden Energy. The substance that would tear the universe apart may not be allowed to exist, and that is the best news in this entire story. We have spent the night taking the phantom seriously, following it all the way down to the last atom, and it is time now to turn the question around and ask whether such a thing can be real at all. Because from the very beginning, phantom energy has carried a warning label. When Robert Caldwell introduced the name in 2002, he chose the word phantom deliberately, and not only for its ghostly sound. Phantom energy has a property that made physicists profoundly uneasy the moment it was written down. It violates one of the conditions that physicists had long assumed any genuine form of energy must obey. That condition has a technical name, but the idea behind it is simple enough to feel. Physicists call it an energy condition, a rule about how energy and pressure are allowed to combine. The particular rule that phantom energy breaks is, roughly, the requirement that energy density plus pressure cannot be negative. For every ordinary form of energy and matter, this holds. For a cosmological constant, with its number W exactly at -1, it holds right at the edge. But for phantom energy, with W below -1, the pressure is so strongly negative that this sum goes negative, and the condition is violated. And when that condition is violated, strange and troubling things become possible in the equations, the kinds of things physicists associate with pathology rather than reality, instabilities, runaway behaviors, and in some frameworks, even exotic possibilities, like traversable wormholes, the sort of results that usually signal that a model has left the domain of the physically sensible. The trouble runs further than an abstract rule, though. When physicists try to build an actual model of phantom energy, to write down a field that would behave this way, the simplest version requires something genuinely bizarre, a field whose kinetic energy carries the wrong sign, a so-called ghost field. In ordinary physics, motion carries positive energy. The faster something wiggles, the more energy it has. A ghost field is one where the opposite is true, where more motion means less energy, and such fields are notoriously badly behaved. A universe containing a ghost field tends to be unstable in a catastrophic way. The vacuum itself can become unstable, able to lower its energy without limit by spontaneously producing more and more particles, positive energy ones, balanced by negative energy ones, in a runaway that has nothing to do with the slow cosmic rip and everything to do with the model simply falling apart. Caldwell and others noted these problems from the start. The phantom, in its simplest form, is a field that quantum theory does not seem to want to allow. So we are left with two possibilities, and I find both of them genuinely fascinating, because they point in opposite directions and yet both are humbling. The first possibility is that phantom energy is forbidden, that some principle we have not yet fully articulated rules it out, that the vacuum instabilities and the ghostly kinetic energy are nature's way of saying no, this cannot be. If that is true, then the Big Rip is not our fate. The number W cannot truly go below -1, and the universe is spared the tearing, left instead with the gentler ends of heat death or a quiet eternal expansion. In this reading, the Big Rip is not a prophecy, but a warning sign, a red flag that appears in the mathematics precisely to tell us that a certain kind of dark energy is impossible. The second possibility is stranger and, in its way, more unsettling than the rip itself. It is that phantom energy is real, that despite all the theoretical objections, the dark energy filling the universe genuinely does have a number ρ below -1, genuinely does grow as space expands, genuinely will one day tear everything apart. And if that turned out to be true, it would mean something profound, that our theoretical objections, all our reasoning about energy conditions and stable vacuums and well-behaved fields, are simply wrong, or at least incomplete. It would mean that the vacuum, the empty space we thought we were beginning to understand, obeys rules we have not yet discovered, rules under which a ghostly, self-strengthening energy is not only possible, but actual. The existence of the phantom would be the universe telling us, in the loudest possible way, that we do not yet understand the emptiness at all. And this is why the question of the Big Rip is not really a question about the far future. It is a question about right now, about the space in this room, about how well we understand the vacuum tonight. If the phantom is forbidden, we are safe, and we learn something about the fundamental rules that govern empty space. If the phantom is real, we are not safe, and we learn that those rules are far stranger than we thought. Either way, the answer is written not in some distant epoch, but in the present-day nature of the vacuum, in whether that one number, measured in the empty space all around us, sits above -1 or below it. Which brings us, at last, to the only honest question left. We have talked about what the phantom would do, and whether it can exist, but what does the actual evidence say? What have we truly measured about dark energy, about that number W, about which side of the knife edge we are on? Because there is real data now, real instruments turned on the real sky, trying to read the value that decides our fate. And what they have found is not a clean answer. It is something more suspenseful and more human than either a yes or a no. There is a further irony buried in all of this, and it is one that physicists genuinely wrestle with. The same property that makes phantom energy so dangerous, its violation of that basic condition relating energy and pressure, is also what has made it a tool for imagining some of the most exotic ideas in physics, like shortcuts through space-time and bridges between distant places. Energy that pushes outward with such strength that it breaks the usual rules is exactly the kind of energy those speculative constructions require. So the phantom sits in a strange position, too useful to dismiss entirely, too pathological to accept comfortably, a possibility that keeps appearing in the equations of physicists precisely because it does things nothing else can do, while carrying warnings that nothing else carries. What all of this means, in the end, is that the Big Rip lives in a zone of genuine uncertainty, not because we are lazy or our instruments are crude, but because it probes the limits of what we understand about energy, the vacuum, and the rules that empty space obeys. A confident physicist in either direction, one who insists the rip is impossible, or one who insists it is coming, is claiming to understand the vacuum better than the evidence allows. The honest stance is suspended between the two. The phantom might be a mathematical mirage that some more fundamental principle forbids, in which case the tearing never comes. Or it might be a real feature of a vacuum we have badly misjudged, in which case the tearing waits somewhere far ahead. And the only way to move from speculation toward an answer is to do the hard, patient work of actually measuring dark energy, of turning real instruments on the real sky and trying to read the value of that one decisive number. So let us see what those instruments have actually found. Part 12. What the data says now. After all of this, the runaway, the countdown, the tearing of atoms, you would want to know the answer. Is the number below -1 or not? And the honest reply is, we do not yet know, and the not knowing is itself the most interesting part. Let me tell you what we can actually measure, because it is genuinely remarkable that we can measure any of it. Dark energy is invisible, untouchable, and spread through empty space, and yet we can study its behavior by watching how the expansion of the universe has changed over billions of years. When we look at distant exploding stars, at the way galaxies are scattered across the sky, at the faint afterglow of the early universe, we are reading a record of how fast space has been expanding at different times in cosmic history. And from that record, we can try to pin down the number W, to ask whether dark energy has behaved like a steady cosmological constant, sitting exactly on -1, or whether it has been something more dynamic, drifting above or below that line. For a long time, the answer was reassuringly dull. Every measurement was consistent with the number W being exactly -1, the cosmological constant, the tame case that leads to heat death and not to a rip. Within the uncertainties of the data, dark energy looked like a simple, steady property of the vacuum, and the big rip stayed a mathematical curiosity, allowed but not favored. The universe seemed to be sitting calmly on the knife edge, or perhaps just a hair on the safe side of it. And for those who found the rip disturbing, that was a comfort. The best evidence pointed to the gentler ending. But in recent years, something has stirred in the data, and it is worth understanding both what it says and how carefully we must hold it. A major survey of the sky, using an instrument built specifically to map millions of galaxies and trace the history of cosmic expansion in unprecedented detail, has reported hints that dark energy may not be perfectly constant after all, that its behavior may be changing over cosmic time. This survey, whose results came in analyses across the mid-2020s, found a preference for what physicists call evolving dark energy, a number ρ that has drifted rather than held fixed. And this finding has been reported at a statistical significance of, depending on exactly which data are combined, somewhere between about 3 and 4 sigma. Let me explain what those sigma numbers mean, because they are the difference between a rumor and a discovery. Sigma is a measure of how unlikely a result would be if it were merely a fluke of chance. A 3 sigma result corresponds to roughly a 1 in 740 chance of being a random accident. Interesting, worth pursuing, but not yet convincing. In physics, the traditional threshold for claiming a genuine discovery is 5 sigma, which corresponds to about a 1 in 3.5 million chance of being a fluke. The hints of evolving dark energy sit below that discovery threshold. They are a serious signal, taken serious people, but they are not yet certainty. The history of physics is littered with 3 sigma signals that faded away when more data arrived. It is also, occasionally, marked by 3 sigma signals that grew into revolutions. We do not yet know which this is. And here is the part that matters most for our story tonight, the twist that connects this data directly to the big rip. The direction in which the evidence leans is, if anything, away from the rip, not toward it. The hints suggest that dark energy today may be a little weaker than a pure cosmological constant, that its number W may be sitting just above -1 at present, on the gentler side of the knife edge, even if it may have been below it in the past. A dark energy that is weakening, rather than strengthening, is a dark energy that does not run away, does not drive the scale factor to infinity, does not tear the universe apart. If these hints hold up, they demote the big rip. They point toward a softer fate, or toward a universe whose ending is more subtle than any of the three simple scenarios. The current evidence, imperfect as it is, whispers that we may be spared the tearing. But, and this is the honest core of the whole matter, the number is not settled, and it may not even hold still long enough to settle. If dark energy truly evolves, then W is not a fixed value at all, but a moving one, drifting over cosmic time, and pinning down its future behavior from its past is a delicate and uncertain business. We have measured it to within a few percent. We have not measured it well enough, or understood it fully enough, to know for certain which side of -1 it will ultimately rest on, or whether it will cross the line again. The fate of everything still hangs, as it did at the start of this hour, on the sign of a single number, and that number is one we are only beginning to read, from a sky that gives up its secrets slowly and grudgingly. So we arrive at the end of the evidence, and it leaves us exactly where honesty demands, uncertain, watchful, and unable to close the case. The Big Rip is not proven, and it is not ruled out. The phantom may be forbidden, or it may be real. The one number that decides between a universe that ends cold, a universe that ends crushed, and a universe that ends torn, sits maddeningly close to the line that separates those fates, and we cannot yet read it clearly enough to know. Which brings us, finally, back to the knife edge itself, and to the strangest realization of all, the one waiting for us at the very end of this long walk through the end of everything. It is worth saying plainly why this uncertainty is not a failure, but a frontier, because there is something genuinely thrilling underneath the suspense. For nearly all of human history, the ultimate fate of the universe was purely a matter for philosophy or faith, a question no one could imagine ever settling with evidence. And now, within a single human lifetime, it has become an experimental question. We build instruments specifically to measure the behavior of dark energy. We map millions of galaxies to trace how the expansion has changed. We are, for the first time, trying to read the ending of the universe not from a sacred text or a thought experiment, but from the actual light of the actual sky. That we can even attempt this is one of the quiet triumphs of modern science, whatever answer it eventually gives. And the answer will keep sharpening, because more data is coming, larger surveys, new telescopes, longer baselines of observation will pin down that number with a precision we do not have today. It is entirely possible that within the coming years or decades, the hints of an evolving dark energy will either firm up into a confident measurement or dissolve back into the noise, as so many promising signals before them have done. The value of W will be squeezed closer and closer to its true position, and with it, our knowledge of which fate we face. We are not at the end of this story. We are somewhere in its middle, holding a measurement that leans one way, but has not yet spoken with certainty, watching a number slowly come into focus that will tell us how everything ends. And whichever way it finally falls, the largest lesson has already arrived, and it is waiting for us in the last thing we have left to say. Part 13. The Knife Edge. The fate of everything that exists rests on the sign of a single number, and that number is not written in some distant place. It is written in the empty space of the room you are in right now. We have come the whole way, from the first mention of that unfamiliar letter to the tearing of the last atom, and back again to the honest admission that we do not know. And I want to end not with a resolution, because there is none to give, but with the realization that has been quietly building underneath everything we have said tonight. The Big Rip, for all its cosmic scale, is not really a story about the far future. It is a story about the present, about the nature of the emptiness that surrounds you at this very moment, about a property of the vacuum that is either sitting safely above -1 or dangerously below it, tonight, in every cubic meter of space you occupy. Think back over the shape of what we have seen, the whole terrifying architecture of the Big Rip, the emptying sky, the loosening sun, the opening ground, the final tearing of atoms. All of it follows, inevitably, from one property of dark energy, whether its number W is below -1. If it is, the phantom grows, the expansion runs away, and everything comes apart in the order it was built, on an accelerating clock that ends in a single, infinite instant. If it is not, the universe drifts instead toward the slow cold of heat death, or some gentler fate we have not yet named. The difference between an ending of violence and an ending of exhaustion, between the cosmos torn apart while still full of light, and the cosmos quietly running down over spans of time we can barely write, comes down to whether one number is a hair above or a hair below the value -1. The sign of a single number, that is the whole of it. And the most humbling thing, the thing I most want to leave you with, is that this number is not the property of some remote object we could point a telescope at and be done with. It is a property of empty space itself, which means it is a property of the space between your fingers, the space inside the walls around you, the space woven through your own body. The same vacuum that fills the room you are lying in tonight is the vacuum that fills the gaps between the galaxies. There is only one empty space, and it has one character, one value of that number, everywhere. When we ask whether the universe will end in a rip, we are not asking a question about the edge of the cosmos. We are asking a question about the emptiness right here. The end of everything turns out to be a question about the here and the now. There is something almost unbearable in that, and something almost beautiful. We tend to imagine the great cosmic questions as far away, out past the last galaxy, back before the first moment, at scales and distances that have nothing to do with our small lives. But the fate of all structure, everywhere, forever, is encoded in the most ordinary and nearby thing there is, the empty space you have never once thought about, the nothing between things, the vacuum you move through with every step and every breath. It has been carrying its secret all along. And whether that secret reads forever or reads finite, we cannot yet say, because we have not yet learned to read the emptiness well enough. So this is where the honest science leaves us, not with an answer, but with a question held open, and a strange new relationship to the empty space around us. The Big Rip may be forbidden, ruled out by the instabilities of the very field that would produce it, in which case it is a warning written into the mathematics, rather than a fate written into the future. Or it may be real, waiting tens of billions of years out, encoded in a vacuum whose nature we have not yet cracked, its clock already quietly running. The current evidence leans gently toward the safer side, toward a dark energy too weak to tear us apart. But the evidence is not certainty, and the number is not settled, and the knife edge remains a knife edge. I find, at the end of this, that I do not feel only dread, though there is dread in it. I feel something closer to wonder at how much rests on how little, and how near the great question turns out to be. You came here tonight to hear about the end of the universe, expecting, perhaps, something remote and cold and far away. And instead the story has led all the way back to you, to the space in your own room, to the emptiness in your own hands, to a single number hovering near a single value that holds the fate of everything in the balance. The universe may end in silence, or it may end in a tearing. We do not yet know which. But the answer is not out there somewhere. It is here, in the nothing all around us, waiting to be read. And so, as you drift towards sleep tonight, consider the quiet space around you, not empty and not passive, but faintly, patiently expanding, holding within it the one number that decides how all of this ends. It has kept that secret for 13 billion years. It is keeping it still. And whether it whispers forever or finite, it is close enough, tonight, to touch. There is a final thought I want to leave with you, and it is not about fear at all, but about intimacy. For all the scale of tonight, the clusters, the galaxies, the billions of years, the question we have been circling turns out to be astonishingly close at hand. We did not have to travel to the edge of the universe to find it. We did not have to look back to the first instant of time. The thing that decides whether everything ends in silence or in a tearing is a property of the plainest, nearest, most overlooked thing in all of existence. The empty space that is everywhere, including here, including the small volume of air, and nothing that surrounds you as you rest. The end of the universe is not filed away in some remote vault of the cosmos. It is dissolved into the ordinary emptiness of every room. And so the emptiness stops being nothing. Once you know what it carries, the space around you takes on a different weight. It is not inert. It is not merely the absence of things. It is the one substance whose character will decide the fate of all structure, holding within it a number poised near a single value, a number we have spent this whole hour learning to fear and to wonder at. Whether that number reads a hair above -1 or a hair below it, the emptiness is not telling us yet. It has held its answer patiently through all of cosmic history, and it holds it still, woven silently through everything, waiting for us to learn to read it. So let the last image be a calm one, even though the subject was not. Somewhere in the quiet space around you tonight is the answer to how the universe ends. Not a distant secret, but a near one, resting in the nothing between all things, close enough that you are, in a sense, already touching it. It asks nothing of you. It threatens nothing tonight. It simply waits, as it has always waited, holding the fate of everything in the sign of a single number, in the emptiness that is nearer to you than the walls of the room. Rest easy. The universe is in no hurry to answer, and whatever it finally says, it has kept us company, faithfully, the whole way here. If there is a single thing to carry away from all of this, let it be a gentler awareness of the emptiness itself. We move through space our whole lives without once regarding it, treating the nothing between things as beneath notice, as the mere backdrop against which real events occur. Tonight has been, in a way, an argument that the backdrop is the main character, that the empty space we ignore is the very thing whose nature will write the last chapter of the cosmos. That is not a cause for dread so much as for a quiet kind of respect. The nothing is not nothing. It is the keeper of the ending, patient and near, and it has been with you all along.